So essentially, I want to speak as an end user of this AgMIP tool. So here's a sample of an economic model, the simple model for global agriculture. So as economists, when we're doing these analysis or forward-looking projections, a key input is really these exogenous shocks. So for example, the drivers of demand, we want shocks of per capita income, population, global biofuel use, and so on. And typically for these economic variables, we know where to get these shocks. For example, population, you could go to the UN Population Division. They have information of the medium variant, projection of population, and so on. Per capita income, we have data from the CIP group. They do forward-looking projections of GDP. Biofuel use, you could rely on the projections by the International Agency or Energy Agency. They have this annual World Energy Outlook that they publish. Now for productivity, that's a really tricky question, particularly for the climate change shocks, because there's no one-stop shop to get these climate change shocks. You have to actually go to these two approaches. So first you have this comprehensive approach. That is what these big institutions typically do. They hire an individual, hey, you need to use these GCM, use these crop models, then churn out your climate change shocks. Now obviously this particular approach is resource intensive. And for me, like being a grad student, I really can't allocate like half of my graduate time there. So what I usually do is do this quick fix approach. That is to look into the literature and see what has been published. So what has been published by IFPRI, World Bank in terms of these climate yield shocks. Now the problem with this approach is you're limited to what has been published. So for example, if you're working on different crops and what is published is just for maize, then you have to look for another source of these climate change shocks. Now what's interesting about this Geoshare AgMIP tool, it's really bridging the gap between these two approaches. You have an archive of these AgMIP outcomes that you could easily access and aggregate depending on the regional aggregation or crops that you're working on. So just a quick demonstration. I used this AgMIP tool and applied it to the simple model. So I designed these scenarios by picking up a crop model, Pegasus, picking up some of the GCMs, the MIROC and GTFL, then also try to create these bounding analysis by selecting these options. No CO2 fertilization, plus the highest representative concentration pathway. That would be like a pessimistic view of climate change that's going to be creating an upper bound of the adverse climate change impacts. And also, I created this optimistic scenario wherein you have CO2 fertilization and the lowest RCP. So the impact of climate change is not that high. Now, within the tool, as Nelson showed you, you could aggregate your climate change yield shocks there according to, in this case, according to the simple model regions. And from there, I just simulated the model, and I calculated the changes in these food security outcomes. Now, I'd like to highlight this particular thing at the bottom, that all of this work has been done in like less than an hour. Actually, I spent more time preparing for this whole presentation than simulating the whole thing, which says a lot. Says a lot. I mean, people typically, especially like learning NetCDF files. I mean, I experienced that. I took like what, probably a month and a half just to learn that. But with this tool, you don't really need to invest that amount of time. So here's just a quick preview of what we could get from the simple model plus the AgMIP tool. I invite you to see the poster that we're going to post, I think, in the reception. That has a more detailed explanation of what I'm doing. So here, quickly, you could see, where's the that's the red button? Oh, okay, there you go. Yeah, usually red button is a bad signal. So yeah, here you could see the changes in caloric consumption relative to the baseline projection in 2050 under this optimistic and this pessimistic approach. So optimistic, so you have actually an increase, slight increase in global caloric consumption. Well, actually it's negligible because it's near the zero axis. Under the MIROC case, this is Pegasus. Then under the pessimistic scenario, you have the highest RCP, no CO2 fertilization. You have this huge reduction in global caloric consumption. Then with this AgMIP tool, you could easily compare, how these yield impacts are sensitive to these GCM outputs. So as you can see here, these ranges are quite different for the MIROC case and also for the GDFL. Now, the cool thing about Simple is we could infer changes on the average caloric consumption back to the changes in caloric malnutrition count, essentially the number of people who are not meeting their daily caloric requirements. And from here, you can see that under the pessimistic case, relative to the baseline projection in 2050, you're going to see probably around 150 million more people who are going to experience caloric malnourishment in 2050 under the pessimistic case. Optimistic case, it's relatively unchanged. So this is just a brief illustration of what we could do with the AgMIP tool. I think it will be an interesting tool, and it will be very convenient for us users to just have this one-stop shop to get these climate change shocks that we could use for these types of analysis. So I think that's it for my presentation. Yep. Yeah, so see the posters for the details.